Good afternoon, students. Today we'll discuss one of the most important name reaction, that is aldol condensation. We have categorized this reaction in four different parts, that is principle, general reaction, mechanism, and applications in synthetic chemistry related to the aldol condensation. First, we'll discuss the principle involved in the reaction. As the name indicates, what is condensation reaction? Condensation means here we are going to mix two small molecules to generate a somewhat large molecule. In case of aldol condensation, we are going to mix two molecules of carbonyl compound, whether it is two molecules of aldehyde or two molecules of ketone. Aldol condensation reaction was reported by Kane in 1838, and it is one of the most important reaction where there is attachment of carbon-carbon takes place. In this reaction, two molecules of alpha hydrogen containing aldehydes or ketones reacts in presence of base like sodium hydroxide to generate beta hydroxyaldehyde. More probably it is aldol because it consists of both functional group, hydroxyl group, and CHO as an aldehyde group. Or if I will take two molecules of ketone, it gives me beta hydroxy ketone. As this reaction, if I will take two molecules of aldehyde, it gives aldol as a product, commonly known as a aldol condensation reaction. Aldols on heating undergoes dehydration, that is removal of water molecule, to generate alpha beta unsaturated carbonyl compounds. Now, what is the general reaction? In this part, we have taken an example of two molecules of aldehyde. Here I have taken a smallest molecule, that is ethanol. According to IUPAC nomenclature, aldehydes are known as alkanals. E of the alkane is replaced by using Al. Here, the longest possible chain present in this molecule consists of two carbon atoms, hence the name is ethanol. The two molecules of ethanol in presence of base like sodium hydroxide undergoes condensation reaction to give 3-hydroxybutanol. I have started the numbering from the carbonyl carbon atom. This is my carbonyl carbon atom. The longest possible chain consists of 1, 2, 3 and 4 carbon atom. As it is aldehyde, it is butanol. Then I will indicate the position of hydroxyl group by using a numerical 3, and in prefix it is indicated as a hydroxy. As this particular compound consists of two functional group, that is aldehyde CHO and hydroxyl group, hence it is also known as a aldol. The same reaction we can carry out for a propanol, that is 3 carbon containing aldehyde. The product that I will get is 3-hydroxy 2-methyl pentanol. Again it is aldol because it consists of aldehyde and hydroxyl group. This 3 indicate the position of hydroxyl group, and this 2 indicate the position of this methyl group as a substituent. Then there are a sequence of steps has been followed to get the product as a aldol. The first step is removal of alpha hydrogen atom. The question arises in a mind, what is alpha hydrogen atom? This is my carbonyl carbon atom to which oxygen is bonded directly. The carbon atom that is directly attached to the carbonyl carbon atom is known as the alpha carbon atom, and all the hydrogens which are attached with the alpha carbon atom are known as alpha hydrogens. When a hydroxide ion, that is nucleophile, attack at the carbonyl compound, these alpha hydrogens which are more acidic are easily abstracted by using this hydroxide ion. As it is abstracted as a proton, it gives its electron to the adjacent carbon atom, that makes this carbon as a negatively charged carbon atom. And as you know that the carbon with additional lone pair of electron carrying negative charge is known as a carbanion. That is also known as a enolate ion. Now this carbanion, which is formed in a first step with the removal of alpha hydrogen atom by using hydroxide ion, behaves as a transition reaction intermediate. As it is highly unstable, it has a tendency to attack at electron deficient site present in the second molecule of ethanol. Here this is your carbonyl carbon atom, that is electron deficient site. Why? Because as it is attached with electronegative oxygen atom, this oxygen pulls the electron towards itself, makes your carbon atom electron deficient. Hence that will make attack of carbanion more easier at the carbonyl carbon atom to generate this transition reaction intermediate. As there is an attack of this negatively charged carbon atom at the carbonyl carbon atom, the pi bond between carbon and oxygen is broken and the electrons are shifted towards more electronegative oxygen atom. Now in step 3 there is a protonation takes place, means we'll use the water molecule to add the proton, that is hydrogen, at the electronegative oxygen atom, and that result into the formation of aldol as a product, that is carrying carbonyl carbon atom and hydroxide ion. Now this aldol after heating results into the formation of alpha beta unsaturated aldehyde. As there is a removal of water molecule, this is known as a dehydration. While removing that water molecule, your nucleophilic hydroxide ion goes with this goes with the electron pair and hydrogen is removed as a proton, and hence there is a generation of new pi bond between your alpha carbon atom and beta carbon atom. Now why it is known as alpha beta unsaturated aldehyde? This is your aldehyde functional group. The carbon atom directly attached to the alpha carbonyl carbon atom is the alpha carbon atom. This is my beta carbon atom. As there is a presence of pi bond between alpha and beta carbon atom, it is alpha beta unsaturated aldehyde. The common name for this compound is crotonaldehyde. Now we'll go to the IUPAC name. I have started the numbering from the carbonyl carbon atom 1, 2, 3 and 4. The longest possible chain consists of 4 carbon atom. Compound have a functional group aldehyde, hence it is butanol, but a second carbon atom consists of unsaturation, hence we have indicated by using the numerical, that is but2, as the second carbon atom consists of unsaturation En and Al for the aldehyde. Now this reaction is also possible for the ketones. Here we have taken a simplest example of ketone, that is propanone. The longest possible chain consists of 3 carbon atoms. The carbonyl group is sandwiched between same alkyl group, that is methyl group, and as it is present at the second carbon atom, the name of compound is propanone. When two molecules of propanone are reacted with each other in presence of sodium hydroxide as a base, they will undergo condensation to generate the ketol. As there is a presence of carbonyl group present between two sp3 hybridized carbon atom, it is your ketone, followed by there is a presence of hydroxyl group, hence it is known as a ketol because it consists of both ketone and hydroxyl group. Again we have started the numbering from the end so that all the functional group get the lowest possible number. While putting that number, we have to take care that your carbonyl carbon atom get the lowest possible number 1, 2, 3, 4 and 5. As it consists of 5 carbon atom, it is pentane, and carbonyl group is present at the second carbon atom, hence it is pentane 2-ONE. At the fourth carbon atom, there is a presence of both hydroxyl group and methyl group. We have arranged them according to alphabetical order, hence the name is 4-hydroxy 4-methyl pentane 2-ONE, also known as a ketol. Ketols also undergo dehydration after heating or in an acidic condition to give a alpha beta unsaturated ketones. Again, there is a one more reaction that is possible with the carbonyl compound under the title aldol condensation. To avoid mixture of product, if I will use two different aldehyde, that is known as a cross aldol condensation. Here we have taken an example of aromatic aldehyde, that is benzaldehyde, which lacks alpha hydrogen atom, and a aliphatic aldehyde, that is ethanol, containing alpha hydrogen atom. The question arises in our mind, why this benzaldehyde does not contain alpha hydrogen? This is my carbonyl carbon atom. The carbon atom that is directly attached to the carbonyl carbon atom is alpha carbon atom. As it is aromatic carbon, we have removed the hydrogen from this aromatic ring, and it is replaced by using this CHO, means this carbon does not contain any hydrogen. Hence benzaldehyde is aromatic aldehyde which doesn't contain alpha hydrogen. Then in this reaction there is no other possibility to form a carbon ion except this ethanol molecule. So it is helpful to avoid the mixture of product, and such a type of reaction is known as a cross aldol condensation, where only one aldehyde molecule bears alpha hydrogen and other aldehyde molecule does not contain alpha hydrogen. Then the compound that is formed is 3-hydroxy 3-phenyl propanol. Again, we have to start the numbering from the carbonyl carbon atom. Longest possible chain consists of 3 carbon atom. Third carbon atom consists of 2 different functional groups, hydroxyl group and a phenyl ring. Hence, according to alphabetical order, we have indicated these two substituents. 3 indicate the position of substituent. Hence, the name of compound is 3-hydroxy 3-phenyl propanol. This reaction has a wide application because here we have condensed 2 molecules of aldehyde or ketone to give a aldol. That aldol, after heating or in acidic condition, undergoes dehydration to give a alpha beta unsaturated aldehyde. Here we have taken an example of synthesis of butene 2-EnAl and butane 1-OL. Now we have taken a 3-hydroxybutanol that is formed through a aldol condensation reaction between 2 molecules of ethanol, which on heating undergo dehydration to give alpha beta unsaturated aldehyde, that is also known as a crotonaldehyde. This particular compound, when undergo reduction, that is addition of hydrogen in presence of reducing agent like nickel, it will convert this sp2 hybridized carbon atom into sp3 hybridized carbon atom with the addition of 1 molecule of hydrogen to generate your alcohol. Again, here this carbonyl oxygen is reduced to generate the final primary alcohol. This reaction is also helpful to convert glycoldehyde into a monosaccharide, that is glucose. If I will take 3 molecules of glycoldehyde and that will undergo aldol condensation in presence of base like sodium hydroxide, it will generate the glucose as a monosaccharide. I think I have cleared some facts about aldol condensation. Thank you for watching this video.